All right. Good morning. Well, I suppose good whenever you're watching this. So, we are here to go over the position notes. So this would be Physics Journal Entry 1, and so I'm just going to talk a little bit about these, and then we're going to do the example problem. So this is all about position. Uh, so our guiding question is, where is an object? And position, right? An object's position will tell you where it is. So a position is a location in space described with respect to some origins. So, um, so some examples is I ran 4 meters from the door. The door would be the origin, and your position would be 4 meters. We are 10 miles north of Seattle. So no, in that case, Seattle was the origin, and right, your position would be 10. An object's position, so in physics, we're going to use kind of a number line. We're going to think about things in terms of a number line. So an object's position is often given on a number line. So, right, meaning you got some negative numbers over here, you have positive numbers here, you have zero, the origin in the middle, and your position, which we use an x to describe, would be, like here's x position 2, and here's x position -3. So that's position, pretty straightforward. We another example of when we use positions is like a football field, right? If we think about a football field, I guess it technically kind of has two origins, but and they flip flop depending on what team you are, right? But like there's the 50-yard line and the 40-yard line; those would be your positions. And so that's another example of things we use or when we use it. A displacement is a change in position. Okay, so displacement is a change in position. So when you go from one position to another position, we call that a displacement. And it's kind of particular. We would call the displacement delta x. And this little triangle here, that's delta. It just means change in. It means final minus initial. So this is kind of the definition of delta is final minus initial. So, and that would be right because it's the change in position, we call that displacement. So you would take your final position and subtract off your initial position. The little zero, like this is called x naught. This would be x final. This is x naught. Not being the British way of saying zero. And and so basically, the reason it's a zero is because it's when time is equal to zero. So that's why it's x naught as opposed to like xi. But anyway, that's just means the initial position means where you start. Your displacement can be positive, which generally means on a number line, means that you're moving to the right or in the positive direction, or it can be negative, which on a number line would mean that you're moving to the left or in the right or in the negative direction. So um, that's kind of what that means. So for example, you could imagine, right, if we were to go from -3 to +2, that would be, right, final position would have been 2, so that's going to be 2 minus -3, which is going to give you a displacement of 5, positive 5, right? Versus if we went the other way, if we went from 2 back to -3, that would be -3 minus 2, because 2 is our starting point. That's going to give you -5 because you went 5 in the negative direction. So that's that. Okay. Next, we're going to look at um, our example problems here. So it says consider driving between Linwood, which is milepost 180. If you didn't know, we have mileposts that are labeled starting at the Oregon-Washington border and going all the way to Canada, and Bellingham, which is milepost 250. What is your displacement driving from here to Bellingham? So real quick, so let's see here. So let's say here's Bellingham. It's at milepost 250. Here's Linwood. right? It's at milepost 180. And right, the Oregon Washington border would be back here, Oregon, Washington at milepost 0. So find your displacement. Displacement is just delta x, which is right, your final position minus your initial position. So that's going to give you, and delta x is what we're solving for because that's your displacement. So that's going to, your final position was 250. Your initial position was 180. And so delta x is going to equal 50 plus 20, 70 miles. So what is your displacement driving back home? So, right, we're going to basically do the same thing. Delta x is final minus initial. However, in this case, right, we started at Bellingham and we went to Linwood, so that's going to be right. Our final position was Linwood, 180, and our starting position even wrote was Bellingham, so 250. And so in this case, our displacement would be negative 70 miles. So, and then next up is what is your round trip distance? So when we talk about a distance, the distance doesn't have a direction associated with it. So it would just be 70, right? Because we drove 70 miles there, we drove 70 miles home, right? So total trip distance would be 70 miles because you drove 70 miles there, plus 70 miles home, giving you a total of 140 miles, right? It doesn't ask this, but just for fun, if you're what was your total displacement? Let's pretend that it asks what was your total displacement, then that would be 0. So that's just, I'm going to put this in a different color because it doesn't ask it, so you don't need to really answer it, but that's just for fun. Your total displacement, because your displacement does take into account the direction that you traveled, your total displacement would be, right, positive 70 plus negative 70, which would give you 0. The other way to think about it is that delta x, right, your initial is x final minus x initial, and your final position was Linwood, so 180. Your initial position was also Linwood, also 180. So that's going to give you a total displacement of 0. Just so two ways to look at that. So you weren't asked to find that question, but that's why I did it in pencil because it's a little bit different. So, but anyway, so that's your example problems. Hopefully that makes sense. The key fact here. So there is an important difference between the distance and displacement. So that was what we were just talking about. So distance is how far you go. That's a scalar. So like that's the 140 from our from part C. And displacement is how far and in what direction. So the reason that that one was 0 when we did, when we did this here, is because we had to take into account the fact that you drove negative 70 coming back. So that cancels out the 70 going there. So it's kind of displacement, how far are you from where you started, is another way to kind of think about that. So if if you haven't learned about what scalars and vectors are, a scalar is just something that doesn't have a direction associated with it, and a vector does have a direction associated with it. So that's the notes for journal entry 1. So thank you very much for watching.